Ever wondered how much stress wood can handle before it gives way? That's what allowable stresses in wood are all about. This concept is a significant component in the world of architecture and structural design, helping to determine the safety and durability of buildings. Central to understanding these stresses is the National Design Specification for Wood Construction, or NDS. This resource provides essential tables that outline the allowable unit stresses in structural lumber and glued laminated timber. It's like a cheat sheet for architects, offering a clear guide on how much stress different types of wood can endure. And with factors such as repetitive use and duration of load, fire-retardant treatment, and size factor adjustments at play, it's a complex yet fascinating field of study. So, the allowable stress of wood is a vital factor in architectural design, but how exactly is it determined? Several factors come into play when determining the allowable stresses in wood. Let's dive in. First up, repetitive use. The National Design Specification for Wood Construction, or NDS, uses a repetitive factor denoted as CR when several beam members like joists or rafters are used together. This factor is 1.15. To use this, the members cannot be over 4 inches thick, and they can't be spaced more than 24 inches on center. They must also be joined by transverse, load-distributing elements like bridging or decking. And remember, you need at least 3 members in a group to apply the repetitive factor. Next, we have the duration of load, which is all about the length of time a load-producing stress acts on the wood. Allowable design loads are based on a normal duration of load, which is generally taken to be 10 years. But if the load duration is shorter, the allowable stress can be increased. For example, it can be increased by 15% for 2 months duration for snow, or by 60% for wind or earthquake loads. Then there's fire-retardant treatment. The NDS states that the effect of these treatments on strength must be considered. So, if you're using lumber or structural glued laminated timber that's been treated with fire-retardant chemicals, you need to get the allowable design values from the company providing the treatment and re-drying service. These factors all play a crucial role in determining the allowable stresses in wood. But there's more to the story. Size does matter when it comes to calculating allowable stresses in wood. In the realm of structural design, it's crucial to consider size factor adjustments. These adjustments refer to the bending, tension, and compression parallel to the grain in visually graded dimension lumber. According to the NDS, these adjustments are made for lumber that is 2 to 4 inches thick. These adjustments are made using the size factors found at the beginning of NDS tables 4A, B, C, and E. But what about larger pieces of lumber? When the depth of a rectangular sawn bending member exceeds 12 inches, the bending design values, denoted as FB, must be multiplied by a size factor determined by a specific equation. CF equals 12 over D to the power of 1/9. So with size factor adjustments, we can more accurately calculate the allowable stresses in wood. So why is understanding allowable stresses in wood so important for architectural design? Well, it's simple. This knowledge is crucial for the integrity and safety of our structures. Architects and structural engineers use these principles regularly to ensure buildings can withstand the pressures of use and the elements. The National Design Specification for Wood Construction provides essential guidelines for determining these stresses. Whether we're considering repetitive use, duration of load, fire-retardant treatments, or size factor adjustments, each plays a vital role in the overall stability of our designs. By understanding these factors, we can tailor our architectural designs to be more resilient and durable. We can create structures that not only meet building code requirements, but exceed them, offering additional peace of mind for those who dwell within. Remember, understanding the allowable stresses in wood is not just about passing an exam. It's also about creating structures that stand the test of time.